Right. Hi all, thanks for attending this talk. So before we dive into the details, first a few words about ourselves. So my name is Johan Mabille. I'm a technical director at Quantstack. I've been working on the Jupyter project for 7 years now, mostly on the backend side. So I co-authored the Zeus stack. I wrote the debugger backend, so for Zeus and also IPyKernel. And in parallel of that, I'm also leading the C++ team at Quantstack developing Mamba. And Jeremy Tuloup, here with me, for those who were not at the first talk, is also a technical director at Quantstack, working on Jupyter for 5 years now, mostly on the front-end side. So he's one of the main contributors to JupyterLab. He works also on Jupyter Notebook, on Voila, and he recently authored JupyterLite. So Jupyter projects has grown a lot during the past decades. The days where it was only IPyKernel and the Jupyter Notebook are far away now, and it has become a huge ecosystem. So it can be hard, not only for the newcomers, but also for developers who have been involved only on certain side of the projects to have big picture and understand how things interact behind the scene. So this talk aimed to help in understanding that. Also, as a disclaimer, we do not claim to be exhaustive because it's not possible. We just want to present some of the components which are the reference implementations of the specifications of this project and which are maintained by the core developers team. And I will now leave it to Jeremy to start with the Jupyter interfaces.
Yeah, thanks, Johan. So we're going to start with the Jupyter interfaces because this is usually what users see first when they use Jupyter. So we are here on the map, so in this green box, and there are a couple of interfaces, so JupyterLab, Jupyter Notebook, but also Voila. Voila is also an interface to Jupyter. So JupyterLab is one of the most active Jupyter interface currently. It allows for you're working with notebooks, but also with terminals, consoles, text editors, and it has a huge ecosystem of extensions, so you can extend it in many ways. You can even build your own JupyterLab if you would like to, so you can just pick some components from JupyterLab and create a new interface if you would like to. And you can start with JupyterLab in your terminal. There is also Jupyter Notebook, so the one that people are very familiar with. Sometimes when you ask users to use Jupyter Notebooks, they say, oh, Jupyter, that's what they have in mind. It's just this notebook on the page. So you see the difference between JupyterLab and Jupyter Notebook. Here it's mostly focused on a single document at a time. The front end is still a web app, and with the Notebook 7, the front end is also using the same JupyterLab components but put together in a different way. And that's the interface you get when you type Jupyter Notebook in your terminal. And there is also Voila. So Voila, it takes your notebooks and it converts them into a standalone web application. You can also customize it with templates or themes. So on the right side here, we have an example with Voila Beautify to make your notebook look much nicer. And so you can present results this way. And to use it, in your terminal, you can use the Voila CLI, Voila My Notebook, and then open the web browser with this. So now we have more applications. So not necessarily something that would be running in a web browser, but we have this nbconvert family of applications. And nbconvert is a CLI tool that you can use to convert notebooks to other formats, for example, to Markdown, Python, or HTML. And you can use the Jupyter nbconvert command in your terminal to convert your notebooks. But if you use a front-end like JupyterLab or a Jupyter Notebook, you can also do that from the UI directly. It's a menu item. Yeah, and now I'm going to leave it back to Johan for the Jupyter backends.
Thanks. So now, let's say you have started JupyterLab, you open some notebook, Python or C++ or whatever, type some code, and you want to execute it. So obviously, it won't be executed in the web app or in the browser. So what's going to happen here is JupyterLab is going to create a message and send it somewhere where it would be executed. So I think one way to understand what happens behind the scene is to just follow where this message is going. So JupyterLab is connected to the Jupyter server through bidirectional WebSocket connection. There are other clients, like the console, that can talk directly to a kernel and not passing through the server. So Jupyter Server is the backend to all the web applications. So it provides core services, APIs, REST endpoints. It is the clients of kernels, so that's the part of the ecosystem that directly talks to the kernel. It's also responsible for launching and keeping kernels alive. So when you refresh your tabs, or when you start a new kernel because you open a notebook, for instance, it's not JupyterLab that does it, it's the kernel responsible for it. And we come back to that later. It's used the same protocol when talking to the kernels as the one used for talking to the web app. So we have different servers. So the first one, the historical one, is a Jupyter server. So it's a reference implementation. It's mono-user, and it's based on Tornado. It's written in Python. We have an alternative implementation called Jupyverse, which is based on async.io, pure Python too. And then on top of that, you can have JupyterHub, which is a multi-user server using Jupyter Server. So basically, if you want to make a deployment for many users, like in a company or in academia, in university, you will just have many Jupyter servers and a hub on top of that. When the Jupyter server receives a message, you need to route it to the right kernel. So for instance, if you have two notebooks, let's say Python notebook with IPyKernel and C++ notebook with, let's say, Xuscling, and you're sending a message from the Python notebook, you need to route it to IPyKernel. So that's the job of Jupyter Server. The way it's done is it's rely on a component called Jupyter Client. So Jupyter Client is a core API responsible for implementing the kernel protocol that I will detail in a few minutes. So this message is serialized thanks to Jupyter Client. Then it's sent over the network, because your kernel can be like locally, but it could be also on a remote machine. And it will be deserialized on the other side, either by Jupyter Client for a Python kernel, for instance, or by another component, Zeus, that I will just present just after. So a few words, about the kernel protocol. So I think the kernel protocol is one of the key components that is responsible for the success of Jupyter, because it's a specification that is totally agnostic to the language. So meaning, if you go through this specification, let's say tomorrow a new language comes out, and you want to use it in Jupyter, you just have to read this specification, you can implement your new kernel, and boom, you can use that in a new notebook in JupyterLab. So as I said, Jupyter Client is a reference implementation in Python. So it's at the core of all the stack we all use here. Zeus is another implementation. I call it referenced, but it's more like native implementation in C++. I will just explain the advantage and the drawbacks of this approach just after. And these two components rely on a middleware library called ZeroMQ. So ZeroMQ is a C++ library which provides a lot of bindings to a lot of languages. So it's really easy to implement a native kernel based on that. So once our message arrives in the kernel, so it's deserialized through Jupyter Client, and then it goes through the machinery of the kernel, and it's routed to the right method in your interpreter. So here we just want to execute some code. So here IPython will be responsible for executing the code. It will just create a response message, a result message, and just like send them back to the web app using exactly the same way. If you send a message to the C++ kernel, it will just be the same, unless we use Zeus instead of Jupyter Client, and just like same routing inside here. So regarding kernels, there are, I think, more than 100 kernels now, so that's just a lot. So IPyKernel is a reference implementation of a Python kernel. Now, if you want to implement a new kernel, you have basically 3 ways of doing it. So the first approach is you can reuse the IPyKernel machinery. So that's a kernel wrapper approach. It's been used for C++ kernel for an old one. So it's easy to set up. That's the advantage. You can have quickly a running kernel. One of the drawbacks is you depend on Python. And for some languages, the redirection of output and input streams may not be super stable. So it depends what you're doing. The second approach is just writing from scratch. So that's standalone kernels like iJulia or IR kernels and many others. So the thing is, you have total control on your implementation. The drawback is you have to go through all the specification of the protocol, and it might not be super easy to implement. And the third approach is so Xus-based kernel. So you can use and rely on Xus, which is native implementation of the protocols. And so you just have to write glue code between the C API or C++ API of your interpreter and Xus. So that's what we have been developing for the past years at Quantstack. So we have between 15 and 20 kernels based on Xus, and it's like quite easy to set up. Now that we have all this machinery, so from the web apps to the kernels, front ends to back ends, we can execute code, but we can do like more things, like start to develop and use widgets. So widgets are libraries which whose component lives on both the backends and the front end sides. So we'll start with the first one, which is IPyWidget, so which is a core widgets component. So we have two parts. The first part is the model, which lives on the kernel side. And it's synchronized over a protocol built on top of the kernel protocol, so that's widget protocols. It's synchronized with a JavaScript, TypeScript library living in the browser. We can share this TypeScript implementation, this front-end implementation, with many different backend implementations. So for instance, XWidgets is a C++ backend reusing exactly the same JavaScript and TypeScript components of IPyWidgets. And it allows you to have the same widgets in the C++ kernels. There are a huge number of widgets libraries, so I won't list all of them. So just mentioning, so IPyWidget, we just mentioned it. IPyLeaflet, which is an interactive maps based on leaflets, and XLeaflet is a C++ backend for it. We have BQplot, which is a plotting library implementing the grammar of graphics. Xplot is a counterpart. There's also IPyVolume for 3D plotting, etc. And I won't just list all of them. Nice thing with this stack, so it's pretty good to when you work alone or a few dozen of people. Now, if you want to scale, and I don't mean hundreds of people, but millions of users, so like at country scale, for instance, it might be super cumbersome to deploy and maintain an architecture for that. And so there is a new beast recently in the ecosystem, which is JupyterLite, and I pass it to Jeremy.
Yeah, thanks. So JupyterLite was not on the map, if you remember the first one, but it uses so many things from the Jupyter ecosystem. So the difference compared to a normal Jupyter is that everything runs in a browser. So the kernels are compiled to WebAssembly, and then they are executed. The code is executed in a browser directly. But JupyterLite is, in the end, just standing on the shoulders of giants. So it's just, for example, the kernels. The Xus kernels are written in C++, and C++ compiles well to WebAssembly, so they can run in a browser. When it comes to the interfaces, JupyterLab and Jupyter Notebook are also part of JupyterLite. There is also Voici, which is a version of Voila, but also running in a browser. And Jupyter Widgets are also compatible with JupyterLite. However, some packages are not there. So there is no Jupyter server, like the one you are used to. Also Jupyter Client and also nbconvert, at least for now, doesn't work in a browser. So it's really this idea of taking all of these blocks that we saw just before and making some kind of package that can run in a browser. And this is the thing you can have in mind. Like on the left side, there are the interfaces. On the right side is more of the execution environments with the kernels. They run, most of them work in a web worker. And you can see that here I'm just taking the example of the Xus kernels because, yeah, C++, you can compile C++ to WebAssembly. So a bunch of them already work in JupyterLite. Not all of the hundreds of kernels that Jupyter supports. No, it's just a couple for now and probably forever. But for example, you can have Python, SQL, Lua, or even for the Nelson numerical language. And you see here that they are still using the same building blocks that we saw before. And here between this component that is called the JupyterLite server, it mimics the Jupyter server, but it's not exactly Jupyter server. It runs also in a browser. It's still the same message passing happening, so it's still speaking the same protocol to the kernels. And when it comes to the interfaces, Jupyter Notebook, JupyterLab, They both support Widgets and Jupyter Widgets, but you can also have other interfaces, for example, the REPL for code consoles. Yeah. And yeah, so that was just a brief overview, even though it's already a lot. And there are way more packages and more things to the Jupyter ecosystem than what we just presented. So there is also a lot of work going on in the collaboration story. So there is a package called Jupyter Collaboration that if you install it, you get real-time collaboration in JupyterLab and Jupyter Notebook. There is also the executable books project with Thebe and Jupyter Book. And there are also alternative Jupyter frontends that are developed by other people. So they are based on the same standards and protocols, but they provide different interfaces. So yeah. If you want to know more about this, there is the Jupyter documentation. It's more like of a meta documentation. So you have an overview of the things we demoed today. And this presentation is also available on GitHub. With that, I would like to thank you all for coming.
OK. Thanks to the speakers. If anybody has any questions, please come down. And we've got some floating microphones if you'd like to ask anything. I have just like a quick question to start off. I wonder, I'm reflecting back on the talk that we just heard from Franklin and some of the conversations that we've had about JupyterLite here. And I wonder if there are ways to connect the sort of like interactive document story that Franklin was talking about with the in-browser execution of something like a JupyterLite.
Can you repeat the question more of a...
Let me try to make it shorter, sorry.
So I think, let me try to rephrase. So I think the question was if there is a way to
like, can you leverage JupyterLite in a static document, like a MIST document?
Yes. I think that's going to be the subject of Steve's talk later today. So I would just do it easily and just refer to that talk. But yeah, I mean, the idea is that there are just so many building blocks, and the fact that it could be very daunting when you look at this, but the advantage of that is that you can just reuse some parts and then create something new. And I think that's what those projects that try to create static publications or interactive JupyterLite website, they try to do. They try to just take what they need from the Jupyter ecosystem and this whole map of projects and make it easier for users or for a particular use case. So I think the conclusion for that would be that there are still, of course, some caveats and not everything will work, but I think it's getting better day after day.
Yeah, and good to know that there's a talk from Steve later on that you should all attend.
Hello, thank you for the wonderful talk. I have another JupyterLite question. So does JupyterLite run all the computation locally on the computer? So, like, for example, could you use it to do computation on sensitive medical data sets? And just to give the example, I do analysis and build environments for medical data. And could this be a way to basically do analysis that I can then share with others?
Yes. So yes, computation happens in the browser. Actually, you can configure JupyterLite to work fully offline if you want, which is quite convenient. You could put it on a USB stick and just give it to someone. And has a lot of advantages, especially when it comes to data privacy. That's something we didn't cover here, but sometimes you don't want your data to go to bigger cloud vendors. You don't want to leak some information or sensitive data. And with JupyterLite, the fact that it runs on your browser, in your machine, then you have a bit more control on that, yeah, for sure. Yeah.
Hello, I'm Patty Mullen. Thank you for your presentation. I'm getting back into Jupyter, and it's hard to understand all of this. I have a question/offer. Can I work with someone to come up with a one-sentence explanation for each one of these concepts and work on getting the wording really tight? A kernel is a way of interacting with a programming language. This is an example, but get the wording really tight so we can get this down to 500 words, 1,000 words. I want to work on this with someone. I don't know who to work on this with.
I think that would be a super cool thing to have somewhere in the docs, yeah. Like explaining, and I think there's been some work on going to make the docs a bit more accessible, especially to newcomers. But yeah, I agree, like that's why also we start with the interfaces, because that's what people usually see when they use Jupyter. But then there are all of these lower level concepts. Maybe it's just a matter of putting, like you suggest, just a sentence next to this kind of, like a glossary, right? Or, yeah.
Talk to me afterwards. I'm interested in collaborating with anyone.
Yeah, sure. That would be great, yeah.
There's also the website that Jeremy mentioned, docs.jupyter.org. That's hosted on a GitHub repository. It's just like github.com/Jupyter/Jupyter. That's the sort of project-wide documentation, and it's intentionally zoomed pretty far out, and it sort of offloads to specific projects for a lot of the details. But that would be a great place for improvements, for sure. And I'm happy to help review pull requests and things like that for that space during the conference.
Yeah.
Is there, oh, get one more.
Yeah, so thank you for the presentation. So it's like a really great diagram with the overview. And my question is regarding the servers. So you mentioned that there is a async.io version of the Jupyter server, Jupyterverse. So what's the difference between the Jupyter server and Jupyterverse? Does it support all the same features like server extensions? And yeah, so is it a plan to bring it together in one server, like because yeah, so I know that for the Jupyter server, Jupyter Notebook, when it was at the beginning, it was like worked in a synchronous way in many aspects.
Cool. No, it's okay. So I'm not the main author of Jupyterverse, so take what I say like maybe not exact, but the author of Jupyterverse is here in the conference, so you can talk with him. It's David Brochau. So I think it's almost, I think Jupyterverse does almost all what the Jupyter server does. Maybe not all the extension works. One of the main difference is it's totally async, so you can just like launch a lot of execution of different cells and will just like run asyncly. While in the Jupyter server, it's just like queued. So you execute cells and the one just after, etc. So that's the main difference. For more details, yeah, I think you need to ask the author.
Thank you.
You're welcome.
Thank you.
All right. If there's no more questions, then we'll just do the switch to the next presentation. Take a couple of minutes. But first, thanks very much to the speakers for your talk.